In this video, what we're going to do is we're going to explore the basics of solving and checking equations. Now, the numbers we use are going to be pretty simple, so you could actually do most of this in your head, but instead we're going to establish sort of some minimum expectations for doing this. Now, the key idea for doing the solving and the checking is that we're going to make use of two main principles. And the first main idea we're going to make use of is this idea called inverse operations. And inverse operations are pairs of operations that are opposites or that cancel each other out. So in this case here, the two most common ones are going to be addition and subtraction, as well as multiplication and division. And if you think about order of operations, these actually connect because addition and subtraction are a pair of operations that go together for order of operations, as are multiplication and division. So we're going to make use of inverse operations when solving these equations. The second thing we're going to make use of is this thing called the property of equality. And this is a really important math idea because the property of equality is how we ensure that we're keeping both sides of a math equation the same. So inverse operations and property of equality. So let's actually use these to solve these two equations. And as I said, these are simple equations, I understand that, but we're really trying to emphasize the use of these two main ideas. So the first equation we have is a minus 12 equals 7. And the reason why we know it's an equation is that we have an equal sign in the middle, and that equal sign is really telling us that what is on the left side of the equal sign is the same value as what is on the right side of the equal sign. So we know we've got 7 kind of already all by itself. Well, something minus 12 has to have a value of 7. Now we could just guess random numbers, but instead we're going to be a little bit more mathematical about it. This minus 12 part here tells us that whatever a is, we're taking away 12. And that leaves us with a total of 7. So instead, what we're going to do is to balance that out is we are going to use our inverse operations, and we are going to add 12 to the left side. And the reason why we add 12 is that that minus 12 and that adding 12 are inverse operations. In fact, they cancel each other out. So to balance that out, I'm going to use the property of equality, and I'm going to add 12 to the other side. So now, what I'm going to do is I'm going to find the total of both sides here. Negative 12 and positive 12, or minus 12 and plus 12, cancel each other out, leaving us with a value of a on the left. And then on the right, we have 7 plus 12, which leaves us with 19. And so in this particular case here, a is equal to 19. So this is just a real simple sort of explanation about what our basics are going to be for solving equations. We're not just going to do it mentally. We're actually going to try to cancel out the operation that's with the a and then do the same thing on the other side. So let's do the same process over here. In this case, we have 4b is equal to 24. So there's the 4b. So right now, we know that whatever b is, it's being multiplied by 4. So we are going to balance that out by doing the opposite of multiplying by 4, which is dividing by 4. And I'm going to use a division bar to show that. And then I'm going to use the property of equality to do that on the other side. Also divide by 4. So inverse operation is how I'm turning that multiplied by 4 to a divide by 4. And then property of equality says I do the same thing on both sides. So now let's actually work that out. 4 divided by 4 is 1, so that cancels out, leaving me with a value of b. And then 24 divided by 4 is 6. Now the other thing that you're going to be expected to do with equations is to check to see whether a provided value is a solution to the equation shown. And the key here is really recognizing this word here, the word solution, and what a solution means. A solution is simply the value of the variable that makes the equation true. In other words, if we plug this given value for the variable into our equation, will the left side be the same as the right side? So let's actually test this. And here's where we're going to use all of our regular And here's where we're going to use our math etiquette for evaluating equations. So I'm going to start with 26 minus e. E is 12, so that goes in parentheses, equals 14. And now I will simply evaluate. 26 minus 12 is 14, and then that is the same as 14. The key here is that you actually have to make sure you finish doing the work. The work is finished when you have this sort of statement of equality at the end. 14 equals 14, a single value on each side of the equal sign. So in this particular case, the values of both sides of the equation are the same, so we will say yes, e equals 12 is a solution, meaning that that value given, e equals 12, makes both sides of the equation the same. Let's try the equation on the right-hand side. This one's a little bit more complicated, but the process is the same. I substitute the given value of 5 for my variable, plus 2 equals 14. Now I'm going to actually do my evaluating. Order of operations would tell me that I would do the 3 times 5 first, so we'll actually work that out, which is 15 plus 2 equals 14. And then I evaluate 15 plus 2, which is 17, equals 14. So now in this case, I have a different statement of equality. I have here saying that 17 is equal to 14. Well, that's actually not the case. They are not the same. So I say no, f equals 5 is not a solution. And that's how we can go through and check whether a given value is in fact a solution for an equation.